Hello guys, hello. So today we'll be doing a quadratic sequence, right? So you guys must know that the original formula for a quadratic sequence in this case, it's Tn is equals to an squared plus Vn plus c. Some people might be familiar with this part of the equation. If you okay, let me just pause right there because we are gonna be doing parabolic functions and all those things. So it kind of like similar like this, right? So either ways, so mind you, we are speaking of a quadratic sequence, right? So what you guys must know is that again, when it comes to an arithmetic, a quadratic sequence, right, is that the second difference between two consecutive terms or numbers again is constant, meaning it's equal, right? So I'll just emphasize that as we go down here, right? So what you guys must know is that okay, in a quadratic sequence we have this three letters, right? We need to find the value of a, b, and c so that we can have an actual equation for the sequence, right? If maybe you are asked to actually give out the formula of a specified quadratic pattern, okay? So you are gonna use this formula. There's only this formula, so you need to find your c, your b, and your a, right? So this three things, this 2a, 3a plus b, and a plus b plus c are the things that you are going to use to find the three letters all the time. So you guys need to know this, okay? So your 2a, in this case, it's equals to the second difference. So some people might not know what I'm actually talking about, but you'll see, just hang in there with me, right? I'm gonna give an example explaining this and this, right? I just need you to know these things first so that you guys must actually know what I'm talking about when you are actually getting into like the real thing in the pattern, but meaning which I'll be giving you an example using the pattern, explaining those things, right? But before that, I just need you to know those things, and then we'll be applying this on our pattern, okay? So I'm saying 2a is equals to the second difference. Remember, I told you, right, Gucci, the second difference I get between two consecutive terms as what terms or numbers is constant or equal, okay? So this over here, this is kind of like the equation kind of for your second difference. Just know the second difference you get from that specified pattern is going to be 2a equals to that second difference you get, and then the 3a plus b equals to the first term. This is the keyword, the first term of the first what? Of the first difference. Okay. And then this, it's equals to a plus b plus c equals to what? The first term of your original sequence. So this one, we are mostly using it to find c. This one we are using it to find a, right? And then when you found your a, you take your a and then you substitute here, and then you're gonna find your b, and then you're gonna take your a and b, substitute them here, and then find your c. So you guys might not know what I'm talking about up there, but let's get into the real thing, okay? So we are given this pattern right here. It's 5, 12, 23, and 38, right? They are saying that this pattern is a quadratic sequence, okay? And what we must do here is find the general term, the formula for this pattern, okay? So know always that with a quadratic sequence, we always have a second difference. You understand? There's the first, actually it's the original pattern, and then the first difference, and then the second difference, and then you pause there because your second difference is constant, meaning it's the same, equal, okay? So what we have right here is our original pattern, which is this one, okay? and then we do our first difference. Our first difference, it's yeah, we actually find our first difference like the way we did with an arithmetic sequence. It's just that with an arithmetic sequence, we only do the first difference because the first difference is constant. But with a quadratic, we have the second difference because our first difference right here, it's not gonna be constant. It's not the same, so we need to take it further. Okay, so we have our original sequence right here, and then the second one right here, it's the first difference from these original pattern, meaning we're gonna take 12 minus 5 to get 7, and then 23 minus 12 to get what? 11. 38 minus 23 to get what? 15, right? So this over here, it's our what? It's our first difference. So since this is not the same, meaning the numbers are like different and everything, we take it further. Again, you see? So we take 11 minus 7 equals to what? Equals to 4. And then 15 minus 11 equals to what? Equals to 4. So this right here is our what? It's our second difference. So we have our first, I've stated them, our first, actually our original pattern, and then first difference and the second difference. We obtain our first difference from what? From taking our T2 minus T1 to get the 7, and then our T3 minus T2 to get the 11, and then the T4 minus T3 to get what? Our 5. And then here we say this one minus this one, it's the difference between the, the numbers, and then 15 minus 11, okay, to get our what? To get our 4. Okay, so now we have our numbers right here from our second difference, first difference, and then our what? Original term. Now we are gonna go back here. Okay, so I said 2a equals to what? Second difference. You understand? So what is our second difference? What is the term for our second difference? Actually, I was just okay, because I actually mentioned here. I just said the second difference because I didn't specify go to the first term or what, because either way it's equal. It's just 4 and 4 and 4. But you can just say the first term from the second difference, but still it's the same thing. Okay, so our 2a equals to what? The second difference, second different first term. Okay, so which is what? Which is equals to 4, you see? And then our 3a plus b, I said it's equals to what? The first term of the what? First difference. What is the first term of the first difference? Okay, this is our first difference term, this pattern here. It's our first difference pattern. And then what is the first term? It's 7. So meaning the first term of the first difference is what? It's 7. So it's going to be 3a plus b equals to what? Equals to 7. And then when it comes to the 5, the original term, I said the a plus b plus c equals to what? The first term of the what? Original sequence. See, this is our original sequence. What is the first term? It's 5. You see? So we are working with this numbers for here to get what? Our a and b and c. Okay, let me just let me just write the numbers again right here. Okay, no, it's fine. So you see, so we have, okay, to find our a, let me do this. Okay, so to find our a right here, I said our a, or our 2a is equals to what? The first term of the second difference. It's equals to what? The second difference. So it's going to be what? 2a equals to what? 4. You see? And then, so we have 2a is equals to 4. But now we need to find a, right? So we need to make a the subject of the formula. We can only do that by what? By dividing by 2 the side, right? But another thing with maths is that what you do on the right or left hand side, you do it the other way you also do the very same thing the other side as well. That's just the general rule. Okay, so since we are dividing by 2 the side, so it means, see, there's the 2, we have to divide by 2 this side as well. Okay, so the 2 and the 2 cancel out, so a remains the side, but this side, when we divide 4 by 2, we get what? We get a 2. So 2 goes into itself 1 time, and then into 4 how many times? 2 times. So a is equals to what? 2. Okay, so to find our b, I said, you come back here, 3a plus b is equals to what? The first term of the what? Of the first difference, which is what? 7. So we are going to say 3a plus b, which is this one, equals to what? The first term of the first difference, which is what? 7. Okay, so we have 3a plus b is equals to 7, but we have our a as well, because we calculated it from here. Okay, so what we are going to do is to take this a and substitute it where we see a here, so that we can get what? We can get our b. So we have, like, so since we are substituting our a, so it's going to be 3 into what? Into 2, and then plus b equals to what? 7. And then we group the like terms together, and the like terms together. So since b is just by itself, we leave it this side, but the 6 we take it the other side, right? So it's going to be b is equals to 7 minus 6. The sign is going to change because it's going the other side. Okay, so 7 minus 6 is equals to what? Equals to 1. So our b equals to 1 in this case. Let me just write it. Our b equals to 1. So now that we have our a and b, we can calculate what? Our c. I said a plus b plus c equals to what? The first term of our what? Original sequence. The sequence that we were given. Okay, so the first term of our original sequence is what? It's 5. So it's going to be a plus b plus c equals to the first term of our original sequence, which is what? 5. Put it here. Okay, but we calculated our a and our b, so we substitute them here to calculate what? Our c, right? So our a, we said our a equals to 2, and then our b equals, our b here, it's equals to what? 1. We put it in, we insert our 2 and our 1 right here, and then plus c, we don't have c, equals to what? The 5. So still in here, still on the stage, we do what? We group our like terms together. So since c doesn't have a partner or anything, we leave it right here. We take the 2 and the 1, we take them the other side of 5. Okay, so when we take the 2 the other side, the sign of 2 will change, because this side was positive, so when it goes to the other side, it's going to be negative. Same applies to the 1. It was positive this side, so when it goes the other side, it's going to be negative 1. Okay, so 5 minus 2 minus 1 equals to what? Equals to 2. So c equals to what? 2. Therefore, you write your formula properly. Okay, you can just say you can just calculate your a and b and c and leave your things right here. You need to write your general formula in conclusion, right? So the tn I get is equals to what? A n squared plus b n plus, that's the actual thing for the quadratic formula. So you insert your a and b and c. So your a is 2, your b is 1, and your c is what? It's 2. So okay, let me just write there. Tn equals to a n squared plus b n plus c. So in this case, what do? You insert your a, b, and c. Our a, as we have calculated it here, it's 2, and then our b, as we've calculated it here, it's what? It's 1, and then our c, it's what? It's 2. So we substitute them. A equals to 2 again. B equals to 1, C equals to 2, right? But since 1 it's just 1, we can just write the formula like this, as in like 2n squared plus n plus 2. We don't have to like write the 1 here, but if you want you can write it still, it's okay, right? But since we have found our formula right here, we need to test it just to ensure that it's okay? So let's use T1. We know that our T1 is equals to what? Equals to 5. See, check it right here. Equals to 5, right? So let's check it. Where you see your n, what do you put? You put the 1, okay? Because you are like finding the T, the term 1 in this case. So it's gonna be T1 equals to 2 into 1 squared in brackets equals to plus 1, which is this one right here, the n right here, plus 2. So it's 2 plus 1 plus 2 equals to 5, and T1 is equals to 5. Then this is true, meaning the formula is what is correct. But in an exam or test, or in school or in a class or something, you don't have to test it on the actual question paper or answer sheet or class book or something. You can just do this, scribble this aside just to be sure. It's just for your own sake. If you want to do it, this part right here of testing, it's not a must, but you can do it if you want to, because I've been doing that for like a while and all those things. So yeah, thank you.